Hi everyone, today I'm going to be talking about normalizing audio sounds in Audacity. Alright, so I'm just going to kind of briefly go over what's happening with the effects and apply that to a sound I've got loaded up here. There's kind of two different ways to normalize things in Audacity and in most digital audio workstations in general. So I'll kind of walk you through both of them. I'm not going to dive deep into everything that's happening. It's just kind of the basics that you need to know to get the sounds you're looking for. If you want to know more, definitely look into that. But that's not what this video is for. If you already know how to do some basic normalization of your sounds, then this is not the video for you. This is, again, how to apply normalization, a little bit about what is happening, and then why you would want to stick that in some of your sound recordings. I personally recommend doing it on just about everything that you do. I think it's a good practice to have, but again, it's not for everyone in every possible scenario. So I've got Audacity right here loaded up, and I've got this short little sound file. This is something I made for another project a while back. It's just kind of a short, I call it kind of earthquake sound, made with some kind of 8-bit Game Boy synthesizers. I'll just play it real quick. All right, so I've got that right there. I'll make it a little bit bigger just so that we can definitely see the changes. So with normalizing, I guess I'll do it first and then break down what exactly has happened. So I'm going to select the whole track, and I'm going to go up to Effect and Normalize. And it pops up this window. So there's a few things you can do. You can do some different kind of offsets with direct current versus alternating current and offsetting some things. I'm just keep that one checked. If you want to play around with what it does when it's off, you can. I just always keep it checked. This box here, it's unchecked right now because this is a mono track. Basically, if you have a stereo track, you can set it so that way that either the normalization applies to everything, uniformly, or it can do all of the left channel as one process and then all of the right as another. And I think if you have a stereo recording, I definitely recommend checking this one because that way it'll help make sure that both the left and right is balanced. Again, that's may not be perfect for every possible scenario, but overall, I would recommend starting there and seeing what you like. This middle box and check, this is what's important. All right, make sure this is checked. Without it, nothing's really gonna happen. But then you have this little dialog box right here where you can pick what level you want to normalize your sound to. Now, I normally put mine at -3, and I'll start with that for there. And you'll see that this will affect the sound, but as we go, in fact, I'll just do it. Boom. And then notice the sound is a lot louder. All right, these peaks are much, much higher. So basically, what has happened, if I were to zoom in a lot, you'll see these samples here. Again, each of these little dots is a digital audio sample. The computer is essentially just taking the audio that would be coming in from a microphone or whatever and converting it into this little number at this point, and this happens many, many times a second. I'm not going to get into all of that right now, but essentially what the normalization process does in this particular method is it finds the highest amplitude peak, the loudest part of the sound, all right? And when we're looking at this waveform, it would have been the highest of these peaks, all right? And it determines how loud that is. And then it figures out the difference between -3 decibels and how loud that peak is. So essentially it takes, the -3 decibels, subtracts the sound from it. Whatever it's left with, the difference between the loudest sound and the target sound, it then increases the volume of every single sample uniformly by that amount. So now this little sound sample is going to be louder, but because it's affected every sample by the same amount. Everything has been adjusted to scale. So if I play this, it's the same sound, it's just louder. Now, part of the reason I do a lot of stuff to -3 dB is just so that there's plenty of headroom so I can make my sounds louder or softer when I'm doing some mixing after the fact. You can very easily pick other things. I see a common one a lot would be -1. If I hit that, you notice now it's a little bit, everything's a little bit louder. Sometimes people set it to 0 dB. That's a little too loud for my comfort because you're right at the edge of clipping, especially if you have a loud sound. It could overthrow some things. So I always start it a little softer, and then I can bump it up later if I need to. You can also normalize things and make them really quiet if you want. If I was to go in and effect normalize and say something crazy like -12, and it shrinks it back down. This is actually more or less what it started with, but you could keep decreasing that target value and get it something really, really quiet if you wanted to. But generally speaking, normalization is used going the other way. All right, so since this was about where we started, I'll just keep this right here. All right, so that's kind of the main process right there. This is kind of the more common and the easier way to do normalization. In fact, if I'm ever teaching students how to do this, is the first one I recommend, just because it's generally easier for them to understand what's going on. The computer finds the loudest sound and then increases everything by the same amount until it is that loudest sound is at a target volume. All right, so I've still got this selected, but now I'm going to talk about the other way of normalization. The loudness normalization is what this one's called here. All right, if you click on that, we get a different menu, but if you look at it, it's got a lot of the same stuff from before. Okay, so you still have the option to normalize stereo channels independently. You could treat mono as dual mono recommended, so I just keep that on. And then the perceived loudness, the RMS. These are just different settings, and essentially, what it's breaking it down to is what humans are perceiving the loudness to be. This is a very different kind of thing. Humans tend to perceive sound on a logarithmic scale, meaning it increases exponentially. So rather than just doing a mathematical everything gets increased by X blanket statement, this process goes through and does a bit more math in order to make it so that now people listening to this will perceive it at a certain level. So if I was to hit this here, this -23, we actually don't get much of a change. If anything, that was about the same. If I do loudness, and I'll put this, I'll say -3. That is now very loud, as you can see. So this is slightly different than the decibel effect. So if I was to go loudness, -6, we're still getting up there. Again, I honestly, if I'm in Audacity, I don't do this one as much. Just because when I learned how to do this, loudness normalization wasn't a thing. This was a new effect from when I learned the program. So loudness normalization, let's go -15, something like that. It's the same kind of thing. It's affecting the sound. So if I were to play it, it just normalizes it all to as if it sounded at that specific sound volume. It's not doing a uniform affecting of all of the samples. Some of them get affected differently, but again, it's that average sound volume is at the point that you tell it to do, but it's not quite in decibels. If you want to look more into the math of that, that's not what this video is about, but if you just do a search for the LUFS perceived loudness, you'll find all kinds of resources on that, or RMS, things like that. You can definitely look into that more outside of here, but that's not what this video is about. So I'm just going to wrap this up by talking about why you might want to normalize your sounds. So if you have a bunch of sound recordings, whether maybe it's a bunch of different tracks on an album or just a large collection of sounds that you may want to use for different things, um, they may not all be recorded at the same level. They could all be slightly different. One could be louder than the other, things like that. If you normalize them all to the same level, then they all have that same peak volume. So you can very easily stick them all together in the same environment. Say, again, you had an album and you normalized all of the tracks to, 0 dB or whatever you wanted to put it to. Then all of the tracks are more or less the same volume. I mean, you still have your louder and your softer ones, but they never go past this too loud of a point. They would never, peak and get distorted. Um, and then you're not going to run into the issue if you listen to one sound and it is very quiet, and the next one blows your speakers. They're all going to be in this same kind of bubble. So it's very good for moving from sound to sound and keeping a relatively even line, but still having some of that dynamic contrast between all of them. So that's kind of the main reason I use normalization. I'm sure there are many others out there, but that's kind of an effective thing I find it for. And then I don't have to do as much tweaking on the mixer if I know all my sounds are starting at the same spot. And then from there, once they're all in the right in the right place, I could bring certain ones up or down individually, just to fit the mix needs. So that's more or less normalizing in a very short nutshell. Again, if you want to learn more about the process, there's plenty of resources online. Just do a quick internet search or video search. You'll find all kinds of people talking about it. I'm not gonna add to that. They, I would just be repeating what they're saying at this point. So that's all.